So in this chapter, we're going to discuss the normal distribution, and we kind of talked about it a little bit in the previous chapter where we had uniform distribution and the continuous probability distribution. Now what we're going to have are a special type of distribution, which is the normal distribution, and we're going to use this distribution the most from here on out. This is going to be the distribution that we use all the way through the end of the semester. So the bell-shaped type of distribution is widely used and even more widely abused. This is the hair dryer at Costco I always talk about. It is widely abused. In some areas that we use it is psychology, business, economics, sciences, nursing, and of course mathematics. Most IQs are normally distributed. Real estate, our economy usually is. It peaks at some places, then we go into recession, then we peak and then go in recession. It's kind of what we call a pattern. Okay, so we want to talk about a little bit about the normal distribution and the characteristics, and then we get to actually apply it. So the first thing is we want to discuss is the characteristics. So the characteristics of a normal distribution, well, first of all, it just looks like this, right? This is the shape that it is. Looks like a nice little bell curve. Okay. The distribution that is in your book that goes with the OpenStax textbook is X is the normal distribution of with respect to the mean and standard deviation. Recall with the uniform distribution, which was the rectangle, recall the distribution was the random variable such that U was with respect to the mean and standard deviation. And then now the normal distribution is N. Okay, so I think we've seen this before. Hey, let's talk about the center. What does the center mean? Well, the center is pretty important because as you recall from chapter 2 when we talked about skewness, we said if it peaked in the middle and trailed off to the left and to the right, that this would be bell curve distribution. Well, at the bell curve at the peak, that's when we said the mean, median, and mode were all equal. Well, because probability under the curve, last time it was a rectangle, recall the probability was equal to the area under the curve. Right? Which probability is at maximum 100%. So notice here, if the probability is a maximum of 100%, then it makes sense why the median would cut this graph in half and you would have a lower half and an upper half. So right where the mean and median lie, that's the halfway point as we know it. So let's go to the spread of the distribution. Now the spread in the distribution is going to be interesting for us, especially right now in our lives. And the reason why you're listening to me over a video rather than in person. We want to talk about the spread of the distribution. And if any of you got a chance to look at that curve regarding the coronavirus, where they talk about flattening the curve. Well, you know what they're really talking about? To the average person that never took statistics, they're just like, yeah, I'm going to flatten the curve. But to us, because we're in statistics, this is going to mean something to us now because we know what's happening with this normal distribution and this curve. So let me go ahead and take you to a picture where it shows this. So this is from the New York State, and notice that here it talks about the normal curve, and then there's one that's higher and flattened out. So this is just a really good example to show that notice that the number of cases will increase as time increases, and it will peak really, really high, and then it'll shoot down fast. So the number of cases will shoot up real fast and shoot down real fast. But notice the number of cases will increase because there are no preventative measures. And also, it supersedes the healthcare system capacity, meaning all those healthcare nurses, doctors that can help these patients with the virus can't be helped because there's just not enough capacity for these people. So this is why we want to talk about flattening the curve, because we want to be able to make this peak so that every single person with this virus can get help, right? So notice that the mean and median, the highest peak is really high. And over here, the mean and median is much lower. Notice it takes much longer on this blue curve to get to the mean and median, right? It's a long slope. Whereas no preventative measures, the orange curve, notice it's really steep and you're just shooting up real fast and shooting down real low. And you're just kind of climbing low, slower and slow. As time goes by, some cases come up. And soon enough, we'll reach this peak where it'll reach the capacity of the healthcare system, but a little bit lower so that each patient with the virus can still get help. And then it'll taper off. That's where we're at right now. What we're trying to do and why we have a stay-at-home order is to make sure that the number of cases that are growing as time goes by slows down. And it slows down enough where as people are getting the virus, more and more people are recovering from the virus because they're getting help from the healthcare system. So what makes it flattening the curve, right? What makes this so high that it exceeds the healthcare capacity system if we took no preventative measures versus lowering this mean and median taking preventative measures? Well, look at the spread. The spread looks a lot wider when we take preventative measures than when we don't. So this has to do with our standard deviation. So let me go ahead and go back to our notes. So the spread of the normal distribution, as we can see, this is the one with no preventative measures, right? This green one. Notice the standard deviation here is 2.5. If I want to flatten the curve like the red curve, right? And even blue is more flat too. Notice the standard deviations are larger than 2.5, right? And to get a really flat one, the standard deviation is 7. So as the standard deviation increases, the mean and median go down, right? The peak of this curve reduces. So if I go back to the coronavirus curve, notice this, I need the standard deviation to become larger to flatten it, meaning this has a higher median if the standard deviation is much smaller. Okay, so let's write something. So here we would say that the standard deviation gets smaller, the higher the peak. And then we could say, and as the standard deviation gets larger, the flatter the curve, and more spread. Okay, so that's what we talked about. We talked about the shape, the center, and the spread.